Good morning, everyone. Today, we will start our new chapter of Geography, chapter number 2, Inside our Earth. Here are the synopsis of this chapter: Introduction, layers of the Earth, rocks, uses of rocks, rock cycle, and at last, mineral. So, let me first start with introduction part. What is happening inside this 12,700 kilometer diameter ball we call the Earth? Some of the Earth's internal architecture is an educated guess mainly from seismology, because the longest drill we have has only penetrated 12.26 km, and there is 6,300 km between us and the center of the Earth. The various layers that make up the Earth's structure: in the center of the Earth is the core, then there is the mantle, and finally the crust. Despite this limitation, we know that the center of the Earth is very hot. We only have to drill a small way to observe temperature rises of some 25 degrees Celsius per kilometer. So at some point, everything might be so hot that we would strike molten rock like the lava that flows from the volcanoes. However, common sense tells us that this rapid rise in temperature we see from surface drilling could not continue indefinitely, or the center of the Earth would be hotter than the sun. The currently accepted theory of the Earth's structure is that it has a core, a solid inner core, and a liquid outer core, a viscous mantle divided into an upper mantle and the lower mantle, and a silicate crust. We believe that gravitational attraction and melting has nicely sorted the composition of the Earth so that dense materials have been pulled to the core, leaving lighter elements on the surface to form the crust. Layers of the Earth, we already know it very well: the crust, metal, and the core. And core, first is core, metal, and crust. Core is bifurcated into inner core and the outer core. Let's start with crust. The crust is composed mainly of basalt and granite, and with the uppermost part of the upper mantle is broken into tectonic plates. The crust is cooler and more rigid than the deeper layers. The thickness of the crust varies considerably. Beneath continent, it is about 30 km. Mountains have a corresponding route within the Earth, sometimes increasing the thickness of the crust to over 70 km. Oceanic crust is thinner than continent's crust, usually 5 to 10 km thick, and it mostly composed of basalt. Second point, mantle. The mantle divided into parts of differing viscosity. It is composed of silicate rocks that are rich in iron and magnesium compared to the crust. High temperature within the mantle causes the solid material to behave in a viscous manner, rather like bitumen used in roading. It can be shattered with a hammer, but over time can flow like a liquid. Convection of the mantle creates the movement of the tectonic plates of the crust and uppermost mantle. It is this plates movement that causes earthquake. And at last, core. Recording the amount of time it takes refracted and reflected seismic waves generated by earthquake to travel through different layers of the Earth has told us a lot about the type and location of things below the crust. For an example, S waves cannot pass through the Earth's core at all, while the changes in seismic velocity between layers cause some waves to refract, bend like light passing between two media such as air and water, and other waves to reflect like light from a mirror. Based on studies of dense meteorites, parts of other planets, we can reasonably assume that the Earth's solid core is composed mainly of iron, 80% with small amount of nickel. The liquid outer core is composed of iron mixed with nickel and trace amount of lighter element. At present, we believe that convection in the liquid outer core combined with the rotation of the Earth causes the Earth's magnetic field. Next topic is rocks. A rock is naturally occurring solid mass or aggregate of minerals. It is categorized by the mineral included, its chemical composition and the way in which it is formed. Rocks are usually grouped into three main groups: igneous rocks, metamorphic rocks, and sedimentary rocks. Rocks from the Earth's outer solid layer, the crust. Igneous rocks are found when magma cools in the earth crust or lava cools on the ground surface or the seabed. The metamorphic rocks are found when existing rocks are subjected to such large pressure and temperature that they are transformed. Something that occurs, for an example, when continental plates collide. The sedimentary rocks are found by diagnosis and lithification of sediments, which in turn are formed by weathering, transport, and deposition of existing rocks. Or we can say that rocks are composed of grains of mineral which are homogeneous solid form for a chemical compound arranged in an orderly manner. Most rocks contain silicate minerals compound that include silicon oxide in their crystal lattice and account for about 1/3 of all known mineral species and about 95% of the earth crust. The proportion of silica in rocks and mineral is a major factor in determining their names and properties. Rocks are classified according to characteristics such as mineral and the chemical composition. These physical properties are the result of the processing that form the rocks. Over the course of time, rocks can transform from one type into another, as described by a geological model called the rock cycle. This transformation produces three general classes of rocks: igneous rocks, sedimentary rocks, and metamorphic. Igneous rocks are divided into two main categories: intrusive and extrusive rocks. Intrusive rocks are also called plutonic rocks, which result when magma cools and crystallizes slowly within the earth crust. A very good example is granite. Extrusive rocks result from magma reaching the surface either as lava or fragmental ejecta, forming minerals such as pumice or basalt. The chemical abundance and the rate of cooling of magma typically form a sequence known as bounce reaction series. Most major igneous rocks are found along this scale. About 65% of the earth crust by volume consists of igneous rocks, making it the most plentiful category. Of this, 66% are basalt, 16% are granite, and 17% granodiorite and diorite. Only 0.6% are syenite and 0.3% are ultramafic. The oceanic crust is 99% basalt, which is igneous rocks or mafic composition. Granite and similar rocks known as granitoid and dominate the continental crust. Metamorphic rocks. Metamorphic rocks are formed by subjecting any rock type, sedimentary rock, igneous rock, or another older metamorphic rock, to different temperature and pressure condition than those in which the original rocks was formed. This process is called metamorphism, meaning to change in form. The result is a profound change in physical properties and chemistry of the stone. The original rock, known as the protolith, transformed into another mineral type or other form of the same minerals by recrystallization. The temperature and pressure required for this process are always higher than those found at the Earth's surface. temperature greater than 150 to 200 degrees Celsius and pressure of 1500 bars. Metamorphic rock composed of 27.4% of the crust volume. The three major classes of metamorphic rock are based upon the formation of mechanism. An intrusion of magma that heats the surrounding rock causes contact metamorphism, a temperature-dominated transformation. Pressure metamorphism occurs when sediments are buried deep under the ground. Pressure is dominant and temperature plays a smaller role. Depending on the structure, metamorphic rocks are divided into two general categories. Those that possesses a texture are referred to as foliated. The remainders are termed as non-foliated. The name of the rock is then determined based on the types of minerals present. And at last, sedimentary rocks. Sedimentary rocks are found at the Earth's surface by the accumulation and cementation of fragments of earlier rocks, minerals and organisms, or as chemical participates or organic growth in water, which means sedimentation. This process causes clastic sediments, pieces of rocks or organic particles to settle and accumulate, or for minerals to chemically participate from a solution. The particulate matter then undergoes compaction and cementation at moderate temperature and pressure. It's called sedimentary rocks. Next topic is uses of rocks. Rocks are very useful things every part of our life. Rocks normally consist of several minerals, some essential. A rock thought of as a mineral environment. Each rock type was formed at a certain specific condition, resulting in the formation of a very predictable group of minerals. Rocks fall into three classes according to their origin. We already know it very well, that is igneous, sedimentary and metamorphic. So here are some examples. Let's first start with coal. A sedimentary rock formed from decayed plant is mainly used in power plants to make electricity. Second, limestone. A sedimentary rock, it is used mainly in the manufacture of Portland cement, the production of lime, manufacture of paper, petrochemical, insecticide, carpet backing, and as the coating on many types of chewing gum. Shale. A sedimentary rock, well stratified in thin beds, it splits unevenly more or less parallel to bedding plane and may contain fossil. Sandstone. A sedimentary rocks more or less rounded, generally thick-bedded, rough filled due to uneven surface produced by breaking down the grains. Used participally for construction, it is easy to work. The red-brown sandstone to tragic age, better known as brownstone, has been used in many eastern cities. Granite. An igneous plutonic rock, medium to coarse grained, that is high in silica, potassium, sodium and quartz, but low in calcium, iron and magnesium. It is widely used for architectural construction, ornamental stone and monuments. Pumice. An igneous volcanic rock, it is a porous, brittle variety of rhyolite and is light enough to float. It is formed when magma of granite composition erupt at the Earth's surface. Basalt. An igneous volcanic rock, dark grey to black. It is the volcanic equivalent of plutonic gabbro and is rich in ferromagnesium mineral. Basalt can be used in aggregate. Marble. A metamorphic, even, granular grain to medium grain and may be uneven granular and coarse grained in calc silicate rock. The normal color is white, but accessory minerals acting as coloring agent and may produce a variety of colors. Depending upon its purity, texture, color and marble pattern, it is quarried for use as dimension stone for statuary, architectural and ornamental purpose. Next topic is rock cycle. Like most earth material, rocks are created and destroyed in cycle. The rock cycle is the model that describes the formation, breakdown, reformation of a rock as a result of sedimentary, igneous and metamorphic processes. All rocks are made up of minerals. A mineral is defined as a naturally occurring crystalline solid of definite chemical composition and a characteristic crystal structure. A rock is any naturally formed, non-living form and coherent aggregate mass of solid matter that constitute part of a planet. The rocks are classified into three most important categories, that is igneous, metamorphic and sedimentary. Igneous rocks form in two different environments. All igneous rocks start out as molten rock called magma and then crystalline or freeze. On the basis of Brouwen's reaction series is a proposed of sequence of mineral crystallization from basaltic magma. Metamorphic rocks, from which sedimentary igneous or other rocks are subjected to heat and pressure from burial or contact with intrusive and extrusive igneous rocks. Meta means change and morph means form. Heat and pressure from burial cause molecules of flat minerals like mica to line up perpendicular to the direction of graded compression. Sedimentary rocks are those rocks made up of pieces of other rocks. We call the pieces of rock the clasts. Clast means broken piece. A clast is a piece of rock broken off of another rock. Clasts of rock are eroded from larger rock transported by wind or water and deposited in a basin. After some period of time, the clasts are litified into a stone. The sedimentary rocks we see today were once gravel, sand, silt, mud or living things. We decide what to name sedimentary rocks based on the size of the clasts that make up the rocks. For most sedimentary rock, this is easy. Sandstone is made up of sand, siltstone is made of silt, and mudstone is made up of mud, and so on. Even volcanic ash can become sedimentary rocks. The only hard ones to remember are conglomerate and breccia. Conglomerates are made up of rounded gravel-sized particles. A geologist, gravel is anything from 2 mm to 4 m in diameter, and breccia is made up of angular, sharp edges gravel-side clast. So, what is the actual process of the rock cycle? Start with cementation. The process by which clastic sediment is litified by precipitation of mineral cement such as calcite cement among the grains of the sediments. Compaction, tighter package of sedimentary grains causing weak litification and a decrease in porosity. Second point is compaction, tighter packing of sedimentary grains causing weak litification and a decrease in porosity, usually from the weight of overlying sediments. Third is deposition, the setting of minerals out of a transporting medium. Fourth one is erosion, the process that loosens sediments and move it from one place to another on Earth's surface. Litification, the process by which sediment is converted into sedimentary rock. This process includes cementation and compaction. Magma, molten rock, generally a silicate melt with suspended crystals and dissolved gases, melting to go from a solid state to a liquid state. Metamorphism, alteration of the minerals and texture of a rock by changes in temperature and pressure. Sediments, materials, for an example gravel, sand, mud and lime, that is transported and deposited by wind, water, ice or gravity. Or we can say that material that is precipitated from solution or deposits of organic origin such as coal and coral reef. Transportation, the process that carries sediments or other material away from their point of origin. Our last topic is minerals. Minerals are defined as solid, inorganic, naturally occurring substances with a definite chemical formula and general structure. Almost all chemical elements in the earth crust are associated with at least one mineral. They vary in color, hardness, density, crystal form, crystal size, transparency, composition, location and abundance. Some minerals are radioactive while others are magnetic. Some are uncombined elements such as gold, silver, sulfur, copper, platinum, etc. Certain minerals such as fluoride, calcium fluoride glow with a vibrant luminescence after exposure of ultraviolet light. Minerals are the most abundant material found in the earth crust. Mankind has coveted many minerals and gemstones due to their striking, beautiful colors. Some specimens of opal exhibit rainbow-like colors within their crystal, while some specimens of the gemstone tourmaline show progressions and watermelon-like green color to pink color from one side to crystal to another side. In simple manner, we can say that minerals are substances that are formed naturally in the earth. Minerals are usually solid, inorganic, have a crystal structure, and formed naturally by geological processes. The study of mineral is called mineralogy. A mineral can be made of single chemical element or more, usually a compound. So my question is, what are minerals made of? Minerals are solid substances that are present in nature and can be made of one element or more elements combined together. For an example, like gold, silver, carbon are elements to form minerals on their own. They are called native minerals. What are the actual uses of minerals? My next question is, economic minerals include energy minerals, metal, construction minerals, and industrial minerals. Energy minerals are used to produce electricity, fuel for transportation, heating for homes and offices, and in the manufacturing of plastics. Energy minerals include coal, oil, natural gas, and uranium. Why do we need minerals? My third question is, just like vitamins, minerals help our body to grow, develop, and stay healthy. So related to this chapter, my question is, what are rocks used for? Rocks and minerals are all around us. They help us to develop new technologies and are used in our daily lives. Our use of rocks and minerals include as building material, cosmetic, car, roads, and appliances. My next question is, what is the least common type of rocks? The least common type of rocks are sedimentary rocks. My next question is, what are the main characteristics of rocks? Rocks are classified according to such as minerals and chemical composition. It is particularly based on the texture of the constituent particles and particle size. These physical properties are the result of the processes that form the rocks. Thank you. Have a nice day.